this video, we're going to solve problem 7 from set 8. We're asking to check a hypothesis over a standard deviation of the population, but that requires us to solve using the sample standard deviation. So we'll have to use what I have called S tilde. Remember, this is 1 over n minus 1, the sum of numbers squared minus the mean squared. For that, we have to start computing the mean. The mean of this is equal to the sum of the numbers, minus 2 plus 4 plus 1 minus 8 minus 3 plus 0 plus 5 minus 1 plus 6 plus 2, divided by the number of points we have, which is 10, as you can easily add. You count. So this is 4 divided by 10 equals 0.4. So to compute S tilde, you could use the variance also, but let me use the sample standard deviation. You can use population, but doesn't matter. 1 divided by 9, square of these numbers, minus 2 squared is 4, plus 4 squared is 16, plus 1, plus 64, plus 9, plus 0, plus 25, plus 1, plus 36, plus 4, minus 0.4 squared, only the 0.4. You do the computation, and this is 17.53777, so let me put 78 here. Okay, so that's the sample variance. Now, if we come to the hypothesis testing, we want to check whether the population's standard deviation is equal to 5. As we are going to later check power of the test for 7, what we'll do here is we'll take as an alternative hypothesis that sigma is greater than 5. Well, actually, this is equivalent to say that sigma squared is equal to 25 or sigma squared is greater than 25. That's the same thing. How do we test this? Well, remember, we're talking about let me put part A here. We're talking about the variance. In that case, we have to use n minus 1 times S tilde squared divided by sigma squared is distributed as a chi-squared with 9 degrees of freedom. The level of we're testing 1%, the significant level 0.01. As is one side the test, we have here our chi-square. We want to look for a point, let's call C star for critical point, where this area is precisely the significant level, 0.01. So we look for a point C star satisfying that the probability of 9 degrees of freedom chi-square greater than C star is equal to 0.01. You can do it in the table, but for this video I will just take a computer and do it, and then it turns out that my critical point is 21.6. So the critical region is the region of rejection. So we are going to reject if n minus 1, 9, divided by sigma squared, 25, times S tilde square is greater than 21.6. Actually, it's 666 or 67. Okay. So, or what is equivalent to this? The same as that S tilde square is greater than 21.67 times 25 over 9. After some rounding here and there, because I have done some of the computations. Anyway, don't worry, this is 60.19. So the region of rejection, or the critical region, is from 60.19 up to infinity. In our case, we have that S tilde, we have computed above here, it was something like 17.53. So 17.5378, this is less than 60.19, so we do not reject. The last part of the problem, part C of 3, it says the probability of making a type 2 error assuming that sigma is equal to 7. That's important. We're going to compute the probability of type 2 under the assumption, that's important to say because this probability changes, assuming that sigma is equal to 7. That's it. We want to compute the probability of type 2, means we do not reject the null hypothesis, but the alternative hypothesis is true, sigma is equal to 7. Okay, so this is when we do not reject the null hypothesis. We do not reject the null hypothesis when our S tilde square is less than 60.19. When sigma is equal to 7. How sigma is equal to 5, sorry. So now condition to sigma equals to 7. Let me repeat it. The probability of making a type 2 error is the probability of not rejecting H naught, meaning S tilde square is less than 60.19, assuming the alternative hypothesis is true. In this case, sigma is equal to 7. Okay, we have to standardize all these things, right? So it's as the probability of 9 divided by 49. Now sigma is equal to 7 by assumption. S tilde square is less than 60.19 times 9 divided by 49. The left hand side is chi squared, because the formula, right? So this is chi squared when 9 degrees of freedom less than, if you compute the right hand side, you get 11.055. I went to a computer to do it, and this is 0.728. So it means beta, the probability of making a type 2 error, in our case, if you want to put in percentages, is 72.8%. The power of the test, that tells whether the test is good or not to detect certain things, the power of the test is equal to 1 minus beta, which is 1 minus 0.728. So that's here 2.720 or 27.2%, which is not a very high power.